Professor Lobster. There's a wise old man from the bottom of the sea. He's come to help both you and me. How things work and how things go. Anything you want to know. So if you don't know, I want to know. If you don't know, I need to know. If you don't know, I've got to know. Just ask. Professor Lobster, build a house for me. Somewhere I can go to watch my TV. Professor Lobster, show me something new. Maybe when I'm older, I'll know as much as Professor Lobster.
Good afternoon, and welcome to the Professor Lobster Show. Here we are inside the Crystal Palace.
When are we, Prof?
We're in the Crystal Palace.
No, not where. When?
Oh, 1851, of course.
You've really done it this time, Prof. You've got us lost in time.
No, we're not lost. This is beautiful. Built in 1851 for a great exhibition.
1851?
Yes, it's as big as a cathedral. Built out of glass and iron.
I thought you said it was crystal.
No, glass and cast iron ribs all connected together to make one of the most impressive spaces that people had ever been in.
It's like a giant greenhouse, really.
Yes, it is. It's a pity it doesn't exist anymore.
Well, what are we doing inside it, Prof?
Oh, just looking.
Are there any more like this around?
Yes, this was the biggest and the best. I'll take you to an earlier one, though.
All right, Prof, I give in.
Why do you give in?
Well, where are we?
Well, can't you tell? This is Kew Gardens, and this is the Palm House. It's a fantastic building. And now for something completely different.
Oh, man, he's smart.
Yes.
You mean you're actually agreeing with me?
Yes, I do. People call it a smart building. It thinks for itself.
Yeah, but it's just an updated greenhouse.
Well, it looks a bit like one, but really, it's an office building in the centre of London. And now, back from the future into the present. Well, what do you think of the greenhouse?
Great!
Yes, I think so too.
What's the egg timer for, Prof?
Well, that's to remind me to tell you that glass is made out of sand.
Yeah, but you can't see through sand.
Well, you can certainly see through glass. Now, let's see what's on the menu. Well, today we've got iron and glass, and more important, we've got frames and connections.
Frames?
Yes, you've got to have frames to hold the glass in. Glass just doesn't stand there on its own. Now, when they made glass in olden days, they made it in shapes like this. And in the middle here, see, where my nose is where they snapped the piece of glass off where they'd been making it. Now, in modern glass technology, they can make much bigger pieces of glass. I mean, you've seen shop windows, enormous things. Sometimes they can make it almost as big as the side of a double-decker bus. Now, it's obviously quite thick, and it's toughened, and it's very, very expensive. But they also design lots of different kinds of glass for different jobs. One of them, for instance, is fire-resisting. This one here has got wire inside it, so that in a fire, it doesn't break, it just shatters, and the wire holds it together and gives it a half-hour fire resistance. It's also obscured, so that you can't see through it. So there's lots of different kinds of glass used in building, and glass is also used for other things. It's sometimes used for very simple objects like this. This milk bottle, it's an everyday object, is a very good use of glass. It's tough, the shape of it's designed to be held, this little indentation on the side is so that you can get hold of it, and they're cheap and reusable and, you know, used every day. Very, very strong. Look at that. Tough. I mean, I don't recommend throwing them around, but they are reusable. Now, this is a lovely piece of glass. What are you giggling at? Look at this piece here. This is called lead crystal. Very fine shape and beautifully cut by grinding wheels here into the thickness of the glass. And the edge is so thin and delicate, it's really quite beautiful. This would cost about £25. The milk bottle, probably about 10p. But just listen to this. Frame up. Now, when you use glass in buildings, you need to have frames round the glass, going round the glass, like that, to hold it in place. Now, what I'm going to do is look at some glasses on 3 wise monkeys over there. Let's go and look at them. Thank you for volunteering to be 3 wise monkeys. Now, the first one here has very light frames. They're very thin. We don't want big, heavy frames because they'd cut out the light. So you keep the frames as thin as possible. Now, this next one, you look like you're going to go on your holidays. You're not saying very much, but these are tinted glasses. And they look a little bit more expensive and they're slightly more pleasurable. You can get coloured glass, you know. And the next one here, these are reflecting glass. And She can see out, but we can't see in, so it's slightly different. Now, there's lots of modern buildings beginning to look a little bit like this. They're certainly very, very different. These are very modern.
Mine are modern, Prof, but yours are old-fashioned. A bit Victorian-like.
They are a bit, aren't they? Small pieces of glass and little frames that go around them. In buildings, the frame is much bigger than a pair of glasses, and on some buildings, like the one we're going to see, the frame can be as big as the ribs of a great ship. Now, a pair of glasses is a small-scale piece of engineering, and they've got to fit precisely. Now, one of the secrets to good buildings is getting all of the parts to fit together neatly, and to make sure all the connections are spot on. Well,
What are we doing at a junkyard, Prof?
this isn't a junkyard, this is a building in pieces. That building over there has been taken to pieces, and they're cleaning all the parts, and then they're going to put it all back together again.
But this is just junk.
No, it's not. This is wrought iron and cast iron, hold that for me, and it's being repaired. This is one of the fixing brackets, and we're going to see where they are in the repair job over there. Now, can you see that? That fits onto there.
One piece of junk fits another.
No, it's not junk, that's a boss. It's a lovely piece of cast iron, and the detailing on this building is remarkable. These wrought iron ribs here enclose a big space like being inside a whale. Now, this was full of palm trees and banana plants.
And rubble.
No, exotic plants that have been brought here because this was the biggest greenhouse in the world when it was built. It was built in 1843 by the Victorians. And what the Victorians were showing was that they were the biggest and the best, and they brought plants from all over the world, from the Empire, from the Amazon. It was like a jungle in here.
Come on, Prof, let's go and see what it's like upstairs.
All right. This is a connection. It's like a knuckle in the building. This piece here is connecting that beam to this bracket, and they're connected to columns, and then the columns have beams in the other direction. The whole thing's like a human skeleton before it becomes a building. And to repair a skeleton like this, you've got to have another sort of skeleton, a scaffolding skeleton. Now I'm sitting right in the top corner of the building, and these three wrought iron arch ribs are riveted together there. And to hold them all together as well the other way, they had a very ingenious idea. They were wrought iron tubular purlins. Now, each piece of this building, when it was taken apart, has been numbered. This is a decorative boss that covers the connection. And an even cleverer idea was that inside the wrought iron purlin, there was a wrought iron tie bar that could be tightened up to hold the whole structure steady. Now, I'm going to put this in place. A piece of historic building, you might say. Now, the purlin slots over the wrought iron tie bar, which will be pushed through it later, and the decorative boss is fitted there. Over 1 million people come to this building every year, and none of them are going to stand where we are standing. Look, here's a connecting plate with bolts and rivets connecting these wrought iron arch ribs coming together, and here we are on top of the Palm House at Kew Gardens. I feel like I'm on top of the world on a day like this.
What do you do with the spaceship in the studio?
Well, it looks like one, but in fact it's a modern greenhouse. Look at all these flowers inside. How are you doing, Petals? But what it really is a geodesic dome.
What does that mean, geodesic?
Well, it means it's like a sphere, like a big bubble, and it's all made out of straight parts. Look at this here. These glazing bars, made in metal, there, are all small straight pieces, all the same length, and they're made into triangles, and they're holding flat pieces, triangular shaped glass, right? So what it is, it's a geodesic structure. That means that it's enclosing the maximum amount of space using the minimum amount of materials.
You mean it's light and elegant?
That's right, yes. And it's very simply made. Look at this connection here. What we've got is 6 glazing bars coming together onto one metal plate with a bolt coming through, and there's a cover plate in bent metal. Simplicity itself. Now, if you were building in outer space or on the moon or something like that, you could do with a structure of this kind, because it's very easy to build. Now, in your lifetime, they'll be building structures like this, and the important thing about the geodesic principle is that it encloses the maximum amount of space with the minimum amount of material, and it's very quick and easy to put together.
Can we go and look at a proper building now, Prof? What about that smart one we saw earlier?
That's a good idea. Let's go.
Where on earth did he go? That's steel and glass. I bet he's in there. Prof, where are you?
I'm up here, Liz! Up here! One of the problems about having a lot of glass in a building is that you've got to clean it both outside and inside. And I'm 8 floors up at present and a bit scared. And I'm on a cleaning gantry. And it goes round and we can clean the inside, but the other bigger problem is solar heat gain. Remember when you put tomatoes in greenhouses, they ripen? Well, people do the same thing in glass buildings. So what this building has is a computer. It's intelligent. It opens the windows when it gets hot, it closes them when it rains, it turns the heating up and down when it needs to, it thinks for itself. In fact, it's a very smart building. Well, that's enough about glass. Let's talk about metal. Now, this soft drinks can is really a tubular structure. It's got very, very thin walls, though, stronger at the top and the bottom. But let's see whether I can crush it. See, that's not bad. Look how it deforms quite easily. Not very strong, is it, that way, at all? Now, the other way, this way, when it's working like a column, providing it's evenly loaded, it's really quite strong. Paper thin, remember, very, very light, so they're cheap. So let's have a little experiment. Can you just move along, please? We'll put this here. Now, come on, Angela, you've tested arches in the past. Let's test this. How much do you weigh?
3.5 stone.
That's about 50 pounds, isn't it? 25 kilos. Now, I'll hold your hand. Stand on it very carefully. You see? Now, it took that. Now, I'm 4 times as heavy as Angela. Do you think I could stand on that and it would be there, or would it crush? Yeah. Well, you're not so sure. Do you really think it would? Yes or no? No! Well, I think there's more no's there, so I'm going to give it a try. Now, I need a little bit of support. That's it, thank you. You're going to catch me in case I collapse. Now, remember, it's about 100 kilos on this, and there we are. Now, if it's deformed in any way, it would collapse. As long as... When Liz hit the can, it deformed. It stopped being a tubular column and lost its strength. Now we're going to see some stronger tubular structures. It's called scaffolding. In order to build structures, you sometimes need to use structures such as scaffolding. This is a tubular metal structure. It's got connections. Look at the way these cast ends on these tubes fix over this horizontal rail. And there's all sorts of fixings here to make it secure, and bracing so that it doesn't topple over, because building can be a dangerous activity. It's also better if you're building in lightweight materials. This is a tubular edge to this column, and this bracing here makes it very strong, and it's amazingly light. Just look at this. You see, one of the advantages of modern building techniques is wherever possible, materials are kept as light as possible, because it makes them easier to erect. You don't need to have cranes all the time. Now, we're going to put this structure together properly in a minute or two, and I'm going to get my team of young helpers to build a building around this lovely, clean, simple frame. But first, we're going to go and look at a very interesting tubular building. I think Lizzie's going to like this one. I told you this programme was about steel and glass. The whole of the outside of this building is made out of it. Steel structure, steel walls, steel window frames and door frames, steel roof. Now, come on inside.
Is this a factory?
No, this is a school.
I'm off. I'm not going back to school.
No, come on, it's a really good interior. Come on.
You promised I didn't have to go to school.
This is a very light, airy space, and it's a very light steel structure. These columns are hollow, they're tubular steel, and so are all these beams, and they're all welded together. And there's some diagonal bracing that's stopping the structure moving sideways when the wind blows. And here we've got diagonal bracing along the corridor, and this stops the building moving that way. And up above us here we've got a steel ceiling. Now there's 200 children in this school, and the sound from the children goes up through those little holes, and above it is an absorbent material that absorbs the sound like a sponge absorbs water.
I like the colour of blue, Prof.
Yes, it's a jolly fun structure.
And I can see by that strut that that's what's holding it up.
That's right.
But I can't see what's holding these things up.
Well, the edge of the canopy, these curved pieces have cables inside. And there are the flying struts.
What's the piece of string for, Pa?
I'm going to fly a kite.
You're going to fly a kite?
Yes, this is very special string. Watch this.
You're cheating again, Prof.
Oh. Well, all this kite flying's fun. There's not a lot of wind today to catch them, but when you get one that is going up, the wind's getting inside the structure and lifting it up in the air. Now, the same thing happens with buildings, like this one over here. This is a very light structure, and the wind can get under it on the edges and tend to lift it. It's a big problem with tents, and it can... Oh, go on, have another try. Go on, run. I'll hold it up and you do it. Okay, pull and run. The wind gets underneath it, and what happens is it tends to suck the roof upwards. The wind pressure can lift the roof, so it has to be tied back and held down very carefully, and it's a very important part of this design. Now, on a real building site, one of the problems is organisation, doing things in an ordered sequence so that the whole thing comes together with the minimum of fuss. Now, what we do these days is we often prefabricate components away from the building site, deliver them on a lorry, and then assemble them. And we assemble them in a sequence. That's the key. Now, the helpers here are going to give me a hand. Can we have a volunteer for a foreman? Oh, well, there's too many volunteers there, so I'll take one pace back and I will elect myself foreman, which is a bit grand and a bit easy. But anyway, I've got to supervise it. Let's have our hats and gloves on, right? And some of you come up on the scaffold. Liz over there is going to be handing the pieces out to the 2 people who are passing them to the other 8 who are going to then bring them to the people up on the scaffold. Now, first to the 4 corner pieces. Right, come on then. Go to the back of the queue, the others. Right, look for that fixing. Nice and easy as it goes down, all the way down. That goes on there. Mind your fingers, plenty of time. You take one end. Okay, mind your fingers. Push it down hard. Give it a bang at the top. I'll give you a bit of a hand. This one goes on there. Wait a minute, this comes over there, like that, okay? You come on. Here we go. Nice and easy. Come on. See, the next one's nearly here. See, we get it. Good. Mind your fingers. No panic. Lots of time. Good. Next. Cars along. Plenty of time. Come on. Oops. Lift it up a little bit. Up a bit. That's it. Thank you. Right. Now, then we need the corner one. Now, they're working very well as a team at present. Nice and quiet. Nice movement to it. Get the next one. Oops. You see, what this shows, this is a cutaway section of the roof to show the construction. Down there we've got the sheet that's making the ceiling, and above that, the insulation. And to keep the insulation dry, to stop condensation going in it, we've got this damp-proof membrane, and then on top of it, the profiled metal sheet. This is just like a typical factory. Now we've done the walls, let's get the front of the building in. Come on. These are in glass. Very nice frame. Drop that one down there. Here we go. That's it, good. Push the bottom in gently. Come on, quickly. Right, now we're going to bring the door in. There's the door, with a very nice little red house and a lovely yellow bow. Oh, that's very sweet. I'll have to come out, I'm going to get stuck in it. Come on, here we go. One of you go inside. You go inside. Now, push that up there. Now, I think you've done amazingly well. I'm really pleased with you. Now, next week, we've got a very heavy show.
What do you mean by heavy?
Well, it's about concrete. Oh, no, come on, that's not fair. Concrete can be a really good material, and there's been some very interesting buildings built using concrete. So watch next week, the Professor Lobster Show. There we are. And remember the motto, if you don't know, ask.
Professor Lobster.